Hello everyone, welcome back to Scribbleaura. Today I'll be explaining about the basics of bipolar junction transistor, which is commonly called as BJT. So let's get started. First is the BJT is a three-terminal device. So what are the three terminals? One is emitter, base and then collector. It is used as a switch in digital circuits and as an amplifier in the analog circuits. Alright, so there are two types of transistor. One is NPN transistor, another one is a PNP transistor, and it is based on the doping. Okay, what is doping? Everything I'll tell you later. Bipolar means in bipolar junction transistor, bipolar means both electrons and holes will help in the flow of current, which is nothing but the conduction process. There are two PN junctions, one is between emitter and base, another is between base and the collector. Alright, now is the internal construction of BJT. Depending on the doping levels, each regions are different. One is emitter region. Emitter is heavily doped. It is used to inject the carriers. The next is a base. Base is lightly doped and it is very thin. And collector is moderately doped to collect the carriers. Okay, so this arrangement will allow efficient current amplification basically. Now, depending on the biasing, there are three regions. First one is active region, next is cutoff region, next is saturation region. So first, what is an active region? Emitter base is when the emitter and base junction is forward bias and collector base is reverse bias. Alright. So how can you say that it is forward bias? Here it is N and here also N minus an N. So it is forward bias. Whereas here it is N and here it is positive. So it is reverse bias. So when the emitter base junction is forward bias and the collector base junction is reverse bias, then it is called as an active region, and this is the condition for active region. The next is the cutoff region. Alright, both emitter base junction and collector base junction are reverse bias and it is called as cutoff region. Basically, if both are reverse bias means the transistor will be off, meaning no current will flow through it. So it is called as cutoff region. Next is the saturation region. Both the emitter base and collector base junctions are forward bias and it is a saturation region. See, this acts like a closed switch, whereas cutoff region acts as an open switch. Alright. Now, if we use PNP instead of NPN transistor, the polarities will be reversed. First thing, the polarity will be reversed, whereas the three modes, okay, active, saturation and cutoff, all three will be exist. But in active region, emitter base is forward bias and collector base is reverse bias. Only the polarity will be different. Same forward and reverse bias only. When the polarity only will be different, and here the condition is this. Okay, and basically active region is used for amplification, saturation is used as a closed switch, and cutoff is used as an open switch. Alright, now we'll see the symbol of an NPN and PNP transistor. Alright, if the arrow of the emitter shows, see, basically this arrow, this shows the current flow. Okay, the conventional current flow only it shows. For NPN, this conventional current flow will be outside, whereas for PNP, it will be inside. Alright. So this is the one thing you have to note it very carefully, and generally we'll use an NPN transistor only. Alright. Now coming on to the next thing, which is different configuration. For common emitter, you can see emitter is common, whereas base is an input terminal and collector will be the output terminal. Okay, and this common emitter configuration is the most commonly used configuration. All right, next is common base. For common base will be the base will be common and emitter will be input and collector will be output. All right, for common collector is a common collector will be the common terminal, base will be the input and emitter will be the output. I hope this is clear. All right, next is a current gain. Okay, there are three currents gain basically. Current gain is nothing but output by input. So it's current gain, so it's output current by input current. There are three. First one is alpha. Alpha is common base current gain. Okay, so it's nothing but it's a ratio of collector current by emitter current is base current gain. Okay, beta is common emitter current gain, which is the ratio between collector and base current, and gamma is a common collector current gain and it is less commonly used, whereas alpha is most commonly used. All right, no, beta is most commonly used. I'm so sorry. Okay, it's emitter current by base current. I hope this is also clear. Now coming on to the working of an NPN transistor. So this diagram shows the NPN transistor works in the active mode. Active mode means what? Emitter base is forward bias and collector base is reverse bias. Alright. Here the electrons are injected from the emitter to the base. Okay, but as we know that base is very thin and it is lightly doped, only a few electrons will recombine there. Most of the electrons will be pulled by this collector. All right, due to how the electrons are pulled by the collector, because of a strong electric field across the collector base junction. All right, that's why collector current is large, the base current is small, and the transistor acts like a current amplifier. Alright, and the image shows that NPN transistor, the emitter base is forward bias and collector base is reverse bias. Okay, if you can see here, the emitter base depletion layer is very small than the collector base. Okay, but I have drew it in the same size, but generally emitter base depletion layer is very small than the collector base. Why? Because emitter base is forward bias and collector base is reverse bias. Alright, when an external potential is applied across the terminals, the majority charge carriers will drift across the junction. Alright, and this drift will lead to the conduction. The electron will move from emitter to the base. Okay, here in base only few electrons will be recombined and the remaining electrons will be moved to the collector. So basically emitter current will be almost equal to the collector current. Right, so this is what you have to like know from this. All right, so emitter current will be almost equal to the collector current. Now coming on to the relationship between, see, first I have to explain about the emitter current, collector current and base current. To understand that, you should know the relation between alpha and beta. Alpha means you know what, it is common base current gain, and beta means common emitter current gain. Alright, so this is a general current equation. I emitter current is equal to base current plus collector current. First, we have to divide the whole equation with IC, which is collector current. So if we divide, IE by IC will be equal to IB by IC plus IC by IC. IC and IC will get cancelled and it is 1. We know that alpha is IC by IE and beta is IC by IB. I can substitute it here. So I'll get 1 by alpha is equal to 1 by beta plus 1. Alright, just take LCM. So it will be 1 by 1 plus beta by beta. So I need alpha, so they just reciprocated. So alpha is equal to beta by 1 plus beta. Alright, so this is a relationship between alpha and beta. To find beta is equal to just nothing but just cross multiply it. Bring every beta to one side and alpha to another side. You'll get this thing. Okay, I hope I've written everything in step by step for you guys to understand it. If there is any doubt, you just comment below in the comment section. I'll help you out. Alright, next is a very important thing. So this is the current equation like IB, IE, IC. So okay, I'll tell you how to derive this also. IE is equal to IB plus IC, which is a basic current equation. Here we know that the base current is very small. In working we saw that, right? So emitter current will be almost equal to the collector current. So this thing you should never forget this thing. This is a very important but very basic thing, but it's very important. We know that alpha is equal to IC by IE. So rearranging this equation, I'll get IC is equal to alpha into IE. I'll just substitute it here. Alright, so it will become like this. I want base current. So IB is equal to IE minus alpha into IE. I'll take IE commonly out. So 1 minus alpha. From here, I can take IE is equal to IC by alpha. Right? So IC by alpha, just substitute it here. So IC into 1 minus alpha by alpha. Alright, we know alpha by 1 minus alpha is beta. In the previous thing, we derived that only. Alpha by 1 minus alpha is beta. Right? So alpha by 1 minus alpha, I'll redenote it as beta. So IC is equal to beta into IB. This is also a very important thing. Or beta is equal to IC by IB. You can derive like this also. Or a general current gain, you know. That is also, so that is actually derived by like this only. And here beta is called as an amplification factor. It's just an, you know, a denotion. Here they are denoting it as an amplification factor. Alright, so IB plus IC is equal to IE. You know, IB plus IC instead of IC, beta IB is equal to IE. So IE is equal to IB into 1 plus beta. So this equation is very, very important. Alright, so that's all, guys. So this is the basics of BJT and everything. I hope everything is clear right now. If you guys have any doubt, you can just comment in the comment section below. I'll help you guys out. Thank you so much for watching my video. Please do subscribe.